Let's see. Here we go. Welcome to the 124th meeting of the BostonVR meetup. Just a few announcements. We'll have our two excellent presentations, and I think a lot sooner than 8:10, more like 7:30, we will go back and play in Frame VR. So let's see. Thank you to XRterra for their ongoing sponsorship. Our thanks to CIC, the place we hope to return to post-COVID, if that happens. We have a digital version of the Venture Cafe. If anybody here wants to load it up in a VR so we can all meet there, that would be awesome. Let's see. I'd like to let you know about the MedVR webinar series. This is attached to the large MedVR hackathon, which will be sometime next year, bringing clinicians and creatives together. The next talk is by Walter Greenleaf tomorrow around noon, and don't miss it. It's amazing. And I already gave my talk, but you can get the recording. That's pretty amazing too. We could use all your support. We want to create, I want to create a working group for online VR platforms. Our first two meetings were in AltSpace VR, and that works pretty well for the people who can get into it, but a lot can't. And Frame VR here has a lot of advantages, but a 15-20 person limit. Anyway, if you want to help us work on that, let me know. Send me an email. I also want to create a working group for equity, diversity, and inclusion. We want to look at what are the barriers to participation in our group faced by people of different ages, socioeconomic status, gender, color, race, nationality, you name it. We want this group to be for everyone, and that means we have to actively figure out how to bring those barriers down. So if you're interested in any of that, send me an email, jeffj@bostonvr.org. And if you feel like sending us money, we're a 501c3 nonprofit, tax deductible. You can send donations via PayPal, check, cash, you name it. So without further ado, let me turn the stage over to Dr. Didi. Let me unmute him. Let's see. I wonder if I can unmute you specifically. Yes. Nope. I can't. All right.
Yes, you did.
It did. Excellent.
I'm unmuted, but actually Anna would like to go first. So if you can change the order. You're muted now.
Anna, where are you?
Okay, I'm here.
Oh, there you are.
Yes.
Okay, good. I will mute myself.
So, yes. First, thank you, Jeff and Didi, for the invitation to be here. I'm very happy to share a little bit of what we do at the Virtual Human Interaction Lab here at Stanford. And as most of you already know about VR, so we will just skip directly for some results and what we have been finding here. Okay, so I will share my screen. All right. And so this is a work that I've done with my colleagues from the lab and also in partnership with University of São Paulo, where I'm also a PhD student there. So when we talk about immersion and learning, so Didi is one of the first scholars to investigate how VR can be used in learning settings and for education. So there is this long-standing interest to use virtual immersive environments for learning. And when we start to look for all the results, all the literature in the last years, we don't find many conversions. So we are starting to see some, but there are still a lot of room for new research and for more investigations on the impact of immersion on learning. And when we talk about learning, we have especially some aspects that are affective. So for example, here we are talking about motivation, engagement, and what the literature shows us is that if we increase immersion using VR, also increase motivation to learn when we compare to other media, for example, computers or television. And when we talk about the cognitive aspects of learning, it's important to differentiate it in two main aspects. So one is the procedural knowledge, that are the knowledge that we acquire when we have using criteria, methods, and when we have techniques, when we repeat them, we have like steps that we have to accomplish. And the conceptual knowledge is where we are when we connect basic elements of what we already know. We connect ideas that we already have a lot of information about when we talk about classification, categorization, and generalizations. So the way the immersion impact each of these knowledge is different. We have been seeing that for procedural learning, we have very positive results from VR and increasing the immersion. But for conceptual knowledge, there is still, this gray area. We are not very sure. Some results are very positive and favoring VR, and some of them are favoring other media. So that's what led and motivated this study. And just to, for some of you that do not have that many experience with VR, we have especially two kind of immersive experiences using the headset. We have the 360-degree videos that we can call immersive VR videos, and we have the computer graphics experiences. So for example, this image, we are having a computer graphic experience where this person, she's crossing this pit through this board. So when we have computer graphics, we can create any kind of environment. So we have a higher interactivity, but the realism is not that high when we compare to a 360 experience video, because the 360 video, we use cameras and we have real images around us. So for this study, we used the 360 cameras and a 360 video. Oops. So for study one, we had 53 female students from the 8th grade from an all-girls private school here in California. And we used two 360 videos, the Crystal Reef and Coral Compass for the condition VR. And we used the exactly same versions, but in 2D. They were recorded using a screenshot recording of these same videos. So you can see, for example, Coral Compass. I added a link for it on my frame. So if you access there, after you can see what kind of video we are talking about. And for that desktop condition, they used a computer. It was a MacBook. And for the VR, they used a Lenovo Mirage Solo VR headset. That's a 3D headset. So for this study, we had that at first they completed a pre-test, a lot of variables we were investigating, but today I will talk just about the learning ones. That's the multiple choices and open-ended questions, and the self-efficacy. That's an effective aspect of learning. 3 weeks after, they were split in 2 groups, the VR group, the desktop group, and in 90 minutes, they experienced VR or desktop. First one video, then they answered the learning questions, then they had the other video, answered the learning questions, and by the end, they answered questions to investigate the feeling of presence and self-efficacy. And the results, what we found was, corroborates the the literature. We had that for multiple choice and open-ended, or it means for the learning questions, the cognitive learning questions, there was no significant difference between the groups, but there was a significant difference between pre and post test. And for self-efficacy, groups, the students that were in the VR group, they scored higher for self-efficacy after having the experience, while the participants on the desktop group, they decreased a little bit their score on self-efficacy. And then we decided to enlarge the sample, and we run the study too. So here we had 139 female students from the same school, and now from 6th to 8th grade. We used exactly the same videos and exactly the same material, the computer and the headset. And we made some changes. So we wanted to see if we would find a delayed result. So we added a delayed post-test after the experience 6 weeks after. And also we broke the experience, the treatment session in two. So we had the pre-test first, all of them answered the learning questions, the self-efficacy questions. Then they were split. In one day they had Coral Compass or Crystal Reef, and on the day after they had or Coral Compass or Crystal Reef, just to not have an effect of order. And after each video, they answered the same questions as the pre-test, plus the presence questions. And 6 weeks after, we repeated exactly the same questions from the pre-test to see if we would find any retention results. And what we found was, for the multiple choice questions, results were pretty similar between two groups, no significant difference at any time. For the open-ended questions, we saw a significant difference, although very little, but a significant difference between the groups, meaning that the students that used VR, they scored higher for the qualitative assessment, the open-ended questions, both after each session, each video they watched, and after 6 weeks as well at the delayed post-test. And for self-efficacy, we found again that students in VR, they scored higher than students in the desktop condition. So from these very fast and preliminary results, what we can say is that the increased level of immersion contributes for the affective aspects of learning, in this case for self-efficacy, and that we found also that it contributes for the qualitative scores on learning and cognitive learning assessments. What corroborates and expands previous studies and give us some leads on how to use those experiences in learning and educational settings. So if you want to experience a little bit of these videos or the slides from this presentation, they're all available at Frame VR in the room that we set over there. I will stop sharing here.
Thank you very much, Anna.
You're welcome.
All right, we'll turn it over to Chris. And after Chris gives his talk, I'm going to give a few tips on how to safely run around in Frame VR, and then we'll meet you in VR. Both Anna has her own frame, Chris has one, and you can ask them, you can go there and ask them questions. Take it away, Chris.
So I want to begin by thanking Anna for coming. I met Anna face-to-face in December at an AI and VR conference and just found her work very impressive. She has just graduated with her doctorate and will be continuing at Stanford with a postdoc. And of course, Jeremy Bailenson is one of the sort of superheroes in the VR world. So it's great that his team is doing such important work in terms of research. And if you have not read Jeremy's book, Experience on Demand, it is kind of a must read and one of the few books that I actually assign in my classes because I think it's so impressive. But let me shift over and talk a bit about why I'm here. And I'm going to do two things. I'm going to share my screen. So you're seeing that. And I'm going to try to make this a little smaller so I can navigate around. And then I'm also going to paste into the chat a URL that you can sort of queue up in your browser, but don't start it yet because you're going to have the chance to watch a video, but I want to set up the video for you. So as you can see from my title, I'm going for the record in terms of number of syllables in a BostonVR meetup title. Pretty impressive, I have to say, for 6 words. Harvard, you know, is noted for being able to say simple things in a complicated way. But let me explain just what this is about. And I'm going to essentially make a brief argument about where things are going, and then look forward to your talking about this with each other, to your talking about this with me, and seeing if we can deepen our thinking about this. So I've been in immersive learning actually for 45 years, beginning with a game called Zork in the late 70s, which was simply words typed on a screen, but it was very immersive. And in VR, as Anna said, since the early 90s. So I've seen a lot of generations come and go in terms of the media. And it's my belief that the key barrier to widespread usage of different kinds of XR is now the human interface that we've developed, certainly in contrast to the late 70s, very rich contexts, very imaginative activities that people can do within those contexts. But we still have totally inadequate and inauthentic forms of human expression. So if you think about the real world and the high bandwidth of the real world, human expression is both verbal and nonverbal. And at the verbal level, beyond the semantics, the content of what you're saying, you can use tone and pitch and prosody and volume to put shades of meaning onto those semantics.
Chris?
And on the non-verbal level,
Chris, are your slides not advancing?
they're not advancing because I only have 2, and I'm
Oh,
saving
okay.
up the second one.
Oh, very good. Sorry.
Yeah, no worries, no worries. I'm having you listen to my argument without being distracted by slides. So on the nonverbal level, there's gesture, there's stance, there's interpersonal distance, there's facial expression, et cetera, et cetera. And so when we're interacting face to face, there's all of these dimensions taking place that are creating meaning. And one of the things that people become very sophisticated at doing is noting, interpreting, and emoting based on all of these social signals. Now you get into XR, and what are we doing? We're using keystrokes. We're using mouse movements. Yes, we can have the verbal if we have a decent bandwidth on the channel, but we're missing some very rich nonverbal things. And so the range of meaning, the authenticity of communication is really very limited. Now you might say, well, what about bodysuits? Well, bodysuits are great. And I love things in the movies where they use a bodysuit to create a raccoon or to create Gollum. But the fact of the matter is that bodysuits are not ever going to be popular in casual use of XR as a way of being able to be authentically human. That's just not going to happen. So what we need, if XR is going to make the next breakthrough, is a killer app. And I was around when the killer app for office computing came through, the spreadsheet. If you had interviewed 10,000 accountants in 1977 and asked what the computer could do for them, not one of them would have mentioned a spreadsheet. And yet within 2 years, it had revolutionized accounting and economics and simulation, and been the killer app that opened up office computing. So is there a killer app for human expression that opens up XR? I think so. And let me describe some characteristics that that killer app would have. It would be a way that you could get much closer to the full bandwidth of human communication. But it couldn't just be like a flight simulator. The great thing about a flight simulator for training pilots is that it can be done purely on the basis of physics. So you can design a flight simulator so that from the human perspective, you want to show an engine falling off or you want to show a thunderstorm, you just press a button and the system does everything else. And it's authentic within the limits of a flight simulator. That's not possible for human interaction. We are not close to having computers that can play human beings at a level of authenticity that makes any sense. And if you've ever tried to interact with an agent, a computer-based agent that's controlled by some kind of machine intelligence, you know how profoundly inauthentic those are, and then it throws off your ability to be able to act with them, interact with them in a meaningful way. So the simulator would have to have the ability to really behave like a human being and to send social signals on all of those dimensions. But so you think the Wizard of Oz. The Wizard of Oz is a nice example of digital puppeteering. You've got the wizard, huge, impressive, emoting in different ways, and then the little man behind the curtain who's actually playing the wizard. That's getting there, but the problem is that the wizard is only the wizard, and what we want is a system that's polymorphic. That is, we want our digital puppeteering to include the ability to change your appearance. So think about Mystique from the X-Men. Mystique is the metamorph that can become almost anybody. That's another part of the killer app, is that not only are you interacting with a simulated human that's authentic, which means it has to be an avatar rather than an agent, because you have to have a person to get the authenticity, but the appearance of the avatar and all of its interpersonal characteristics need to be fluid so that it can assume many different types and many different forms. And what falls short, if you say, well, why don't you just use people for doing role play, is that people with some training can do role play, but they can't change who they are. And so it's not polymorphic, and it becomes very difficult to get that feeling of authenticity if students are role playing for each other, or even if an actor is role playing for a student, because actors are not Mystique. They can't change everything. So the killer app has to have digital puppeteering that's polymorphic, but it also needs to have scripting, because in a human interaction, typically people, unless they're just kind of casually passing the time of day, will have goals in how they're interacting. And if you look at how movies and stories evolve, there's a script, and actors learn how to interpret and carry through the script. And so for really convincing interactions, you have to have scripts that make this killer app work. So now I can show my second slide. And that is a system called Immersion. Now, Immersion is a company, and I am an advisor to the company, full disclosure. But this is not a talk about immersion. It's a talk about the type of system that immersion represents. And so what I'm giving is a generic description of which immersion is one example. So in the slide on the left, you see the kind of range of polymorphism that the system is capable of, where the settings can be fluid, the avatars can be of very different types from one another, and the puppeteer can control single people, but can actually control up to 5 different avatars at the same time, and with advances, perhaps that will become more than that. So in the image on the right-hand side of the slide, you see on the left, the simulation specialist, who is the puppeteer, who has a lot of specialized equipment to morph the voice, to use things like a game controller to create the gestures and the nonverbals of different kinds. Some of those things are hardwired in to the avatars. And then on the right-hand side, you see the participant. And it's a mixed reality because the participant is interacting with digital people in a virtual context, but the participant is in the real world. So the participant has the full range of verbal and nonverbal signals that they can send that the simulation specialist sees and can respond to. And then the simulation specialist gets the puppet to exhibit a broad range of the same kind of signals. So that's where the state of the art is right now in immersion and in similar kinds of systems. So where is this going? Well, first, let me show you what it looks like at present. So what I'd like you to do in a minute is to look at a 3.5-minute video by clicking on that URL. What you're going to see is a student in a negotiation class at the Harvard Business School who is practicing negotiation skills in this killer app, this sort of flight simulator for interpersonal skills. And the student has been told that the script that they're enacting is that the student's talking to bosses, executives in the company for which he works. The company has been in hard times, it's losing money, it's laying people off, but the student wants a raise. So the student is in the difficult position of trying to negotiate a raise in a company that's struggling. So with that as background, remember that everything that you're going to see in the 3.5 minutes is played by the same simulation specialist. Take a look at the video, and then when you come back, raise your hand so that I can see that you finished the video, and then I'll talk about where I think this is going.
Can you post the video link again?
Yes, I'll post the video link right into the chat.
Thank you.
So when you're done with the video, just raise your hand so I can see who's finished. All right, so let me make a couple points about what you saw. One of them is that this student decided to go big or go home in terms of the negotiation. So this was not something that the simulation specialist had been prepared for. In fact, in a class of roughly 50 students learning negotiation at the Harvard Business School, you would see an incredible array of different strategies that students would try. And the ability to handle the full range of that array requires a simulation specialist who understands negotiation and who can manipulate the digital avatars in order to respond appropriately. The second point that I want to make is that if the student had been trying to negotiate where a lot of what they were doing was making keystrokes and moving their mouse around, they wouldn't have learned anything useful in the real world. Because of course, when you go into a negotiation setting, you have to have that range of verbal and nonverbal signals to be effective. So they're actually able to practice in a very authentic way. And the polymorphic part is important, as is the control that the system enables, because what you might do would be to put the student through some paces over time in which sometimes the boss was female, sometimes the boss was older, sometimes the boss was a different ethnicity. And so you can pick up on different kinds of implicit bias or weaknesses in negotiation. Maybe the boss delivers a microaggression that the student has to learn how to handle, or the boss makes a deal and then in the next session goes back on their word, and you have to have a strategy dealing for that. So this is like a flight simulator for negotiation, if you will. So what's the bad news? Well, the bad news is that right at present, there's some definite limits on this. Making digital avatars that have some hard wiring in them so that they have personalities, and the simulation specialist doesn't have to create everything, just is able to create some of the nonverbals, is a complicated process at present, although it's getting easier. It's also very complicated to use a game controller to do the nonverbals, and profoundly inauthentic for the simulation specialist. So the participant has a very authentic experience, but the simulation specialist is dealing with kind of a nightmare interface in terms of what's going on. And finally, at the present state of the technology, it's good if the simulation specialist has some background in acting. Certainly they're going to need to be very quick at improv, thinking on their feet, sending appropriate voice signals, making the right kinds of gestures, and so on. It's not a simple task to learn. So right now, these systems are limited in terms of their cost and scalability, and the availability of simulation specialists by the weakness of the technology. So why am I giving this talk? I think things are about to change in a couple ways that are really important. The first is that artificial intelligence, machine learning, and what's called multimodal learning analytics is getting to the point that if a person does the verbals, the AI can do all the nonverbals. In other words, the AI in real time can listen to what I'm saying and how I'm saying it. And then for that puppet, do all the appropriate gestures, facial expressions, interpersonal distances, body postures, everything else that goes with that. And that really simplifies the job of being the simulation specialist, because most people can do a reasonable job of acting if verbal only is what's going on, and if it's a familiar role that they understand the script. What makes it really complicated is if they've got to do the nonverbals, where they may not be very expressive. So once you have a system that basically reads the verbals and does the nonverbals and is polymorphic, instead of having a simulation specialist, the professor teaching negotiation can use a teaching fellow, or maybe a successful former student, because they understand the content and they understand the script, and the system is capable of doing a lot of the puppeteering. So that's one kind of breakthrough, that now you don't have to have an expert other than an understanding the script and having reasonable verbal facility to do the simulation specialist role. Now, I'm oversimplifying here because certainly it's difficult for adults to play children. It's difficult for people of one race to authentically portray people of another race. So I'm not trying to suggest that anybody can do anybody, but at least that's getting a lot easier. But still, you know, I mean, education is a niche market. Nobody is going to spend a lot of money developing something like this for education because it's not profitable enough. I've gone to gaming companies and argued about making educational games instead of entertainment games, and they just laugh at me. They say it's so much easier to make an entertainment game and it's so much more profitable to make an entertainment game that we can't possibly mess around with doing education games. Education always gets hand-me-downs from the entertainment industry, which isn't necessarily bad if those hand-me-downs are powerful. So what's the killer app? The killer app is if we make this bi-directional. So if just about anybody can be the puppeteer, you can puppeteer your puppet and the other person can puppeteer their puppet. And now you've got polymorphism on both sides. So some of you may know about games like The Witcher, right? Massively multiplayer RPGs where you have a character and your character encounters a whole bunch of other characters along the way. And because the human interface is so rotten, what you end up with is being in interesting contexts and doing interesting things, but not really having interesting interactions because you can't do all the stuff that I've been talking about. But now if you're the Witcher, you can have your Witcher puppet. You can portray the Witcher as having your personality, have the AI pick up the nonverbals, have your Witcher express themselves. And if you're negotiating with the powerful sorceress, who is your next possible ally or possible opponent in this complex swords and sorcery fantasy world, your friend, or maybe a crowdsourced kind of service can play the sorceress. So maybe you and somebody else who has another permanent role within the game kind of play back and forth with each other, or you have people who basically make their living by understanding, oh yeah, I can make now $2 by having this really interesting sorceress conversation for 3 minutes with so-and-so, and they want me to be angry, or they want me to be seductive, or they want me to be this or that, and so that's what I'm going to do. And games could then be written for that, so that now games kind of skim over the interactive part and just focus on the action. But games could be rewritten to do that. Now, if you get to the point that for a couple $100, you can have one of these setups, that's a killer app. Because once you've got it for entertainment and people are doing it for their MMORPGs, education can just piggyback on that and doesn't even need the bi-directional in order to make it work. So the claim that I'm making is essentially that within 5 years, we could be in this situation. And once we make the breakthrough in mixed reality, we can then try to port it into other forms of XR. So I'm happy to talk about that in the frame afterwards and give more details about negotiation in particular as a really interesting kind of test case for this. Do I think that this is happening? I don't know, because I'm sure that whatever is happening is highly proprietary, because whatever company makes the breakthroughs first and gets the patents is going to make an awful lot of money. But I would be astounded if people are not working on this. Because if I can figure it out, certainly people in the gaming industry can figure it out and understand its potential value. So I hope that was interesting to you. The other thing that I want to talk about is that my colleague, Sherry Metcalf, Dr. Sherry Metcalf, is part of our EcoLearn team. This is through the monitor immersion, like an internet game. And she has a very elegant frame with lots of different kinds of resources in it that show what we've been doing with a curriculum called EcoMod, which is for 3rd graders and lets them both be ecosystem scientists and computer modelers within the curriculum. And it's pretty amazing what 3rd graders can do when you give them the right kinds of XR to work with. So I hope you'll stop in and see Sherry. I hope you'll stop in and see Anna. I hope you'll stop in and see me. And thank you, Jeff, for making all of this possible. You're muted.
You're welcome, Chris. Let's see. Yes. And thank you, Anna. Let's see. We have a long tradition is that we have an open mic moment for anyone who has an announcement or a request to the community. Take it away, Emily.
Thank you. Hello, everyone. I am Emily Smith. I'm from IMET, Immersive Medical Education Technology. My colleague Isaac, I see in the red hat as well. And we are located in Toronto, working with a team of surgeons there in Boston. We're doing a project July 11th and 12th, tentatively, and we're looking for a couple of team members. We're looking for an audio recording technician, a camera assistant, and a production assistant, probably for those 2 days. So I'll post the details. Where would be the best place for me to post the details? In any case, you know what I'll do? I'll put my email in the chat. Yep. And anyone who might be interested can shoot me an email.
Emily, post that as a comment on the event site at meetup.com.
Okay, I will do that. Post it
yeah.
as a comment, and yeah,
Great.
looking for some help. So if you know anyone, please send them in our direction.
Super. All right. So let's get on to VR. Let me show you just a couple of tricks. We have 6 frames going. These are the links to them. They're also, the links are on the BostonVR event page. The first one is created by Dr. Sherry Metcalf, showing the work that she and Dr. Didi did together. The next 2 are open play spaces where you can create things, make art, and interact with the VR. The mixer is just a place for conversation. And Anna has a room. She'll be there ready to talk with you and answer questions about her talk. And the digital puppeteering room is Chris's room. So technical tips. Be sure to wear an audio headset. Otherwise, you're going to create an echo for everyone else in the room. That is if you're on a desktop. If you're on the Mac, use Safari or Firefox. FrameVR does work in most VR headsets. There is a limit of about 20 people per frame, which is why we did the talks in Zoom. And all 6 frames are connected by portals. So I'm going to leave the Zoom running if for any weird reason you guys need it as a 7th discussion space. So thank you all for coming, and I'll see you in FrameVR. Oh yes, and I'm recording this. I recorded this whole thing, and I'll post it on the event page. All right. So let's see. Unmute everyone. All right. And I'm going to stop recording.